CL, NML, AED, and AEN. All of those could, the order of the letters doesn't actually matter because we're talking about like angles or whatever. So as long as you had those three chunks of letters or whatever. All right. 18 is segment AJ, segment BK, segment CL, or segment DM, any one of those. 20 is segment AE and segment ED, or that's not and, but or, sorry, my bad. Number 22 is line R because of consecutive interior angles. 24 is line V because of corresponding angles. Excuse me. Number 26 is line S because of alternate interior angles. 28 is line V because of alternate exterior angles. 30 is line V because of alternate interior angles. Number 32 is line A because of consecutive interior. It dawns on me that consecutive, that's same side interior, same thing, right? Either one of those, that's fine. 34 is line D or line F because it's a linear pair. And 36 is line A because of alternate interior angles. What questions do we have, kids? 32. Okay. All right, let me get some amount of that picture. Remind me to not erase it. We might need it again. We might need the other pictures, so that's why I'm showing it in the corner. The street's going like this, and the street going like this, right? Something like that, yeah. And then we've got a street that's coming here. Dawned on me that what I could do is I could take pictures of all of these on there ahead of time. That would be smart. Then we could just do that. But I'll do that later. For today, this is good enough. And then we got one more here. So something like that. And you said 32, right? So 2 and 4, 2 is right here, and 4 is right there. And it says identify the transversal. Okay, let me label all the lines real quick. It's got those. This is A, this is B, this is C, this one, this is D. Okay, so, I wonder if I can boost that any. It's going to be echoey terrible, but. Yeah, we'll boost it up a little bit, that way we can hear. Okay. Alright, so identify the transversal connecting each pair of angles in the photo of the fire escape show. Oh, it's not a road, it's a fire escape. Sure, why not? Then classify the relationship between each pair of angles. So for 32, we're looking at 2 and 4. So this one and this one. So what are they? And which line is the transversal? What is a transversal? Intersects or crosses or something like that. That's probably what it says.
2 or more corresponding lines.
Sure, great. So with 2 and 4, which line is the transversal? Which one is crossing more than one line?
2.
2 is the angles. Which line? So the letter.
B is only one of the two lines, right? A is the one that's crossing through the two lines that go with 2 and 4, right? So B is, excuse me, not B. A is the transversal, right? So that'd be the answer to the first part. And then 2 and 4, what are they? Are they corresponding? Are they a alternate interior, alternate exterior? Are they same side interior, same side exterior? What are they? They're same side interior. True, true. That's true, true, true. Okay, so what else? $20, you said? Okay. Number 20, that's the other picture, isn't it? Oh, no, it's not even a picture. Well, it is a picture, but I'm not going to worry about doing a straight edge for this picture. I'll just plump it over here. Is it a pentagon? Yeah. And down and over and more down. And this one. And I'll dot mine. And A, B, C, D, E. And then J, K, L, M, and N. And number 20 says, a segment skew to CE through point E. Okay, so let's see if we can find all the players. Okay, so there's C, and there's E, right? Oh no, I can't read. CL. There's E, and then there's L. It's like CE is not a line. I'm confused. Okay, great. So we want a line that is a line segment that is skewed to segment CL and passes through E. What does skew mean? No, okay, so what you mean is by parallel kind of but not is that they never cross, right? Skew lines never cross, but why are they not parallel? They're not coplanar, they're not on the same plane, right? So we want a segment that passes through E that isn't in the same plane as this. So it can be on this plane or this plane, right? Those are the planes that CL has, this one and this one, right? So it has to be a segment that is not in those planes, but that will never cross this line. There are at least two options, right? Answer. Can you give us two options? Yeah, they do. They sure do. Which one? E what? EN. So EN is they don't have any drawn that are in the same plane, right? But it would be in a plane that isn't drawn here. So EN doesn't really quite work. Because even though the planes aren't drawn, there would be one slicing through this prism like right here that's in the same plane as these. So that one doesn't quite work. So let's to help us out, right? neither is this one. So either one of those work. ED or EA. So NA is skew to it. NA would be this, that line is not drawn, but it is skewed, but the insurance give us two criteria. Has to be skew and pass through E. So NA, it would be skewed to CL. It just doesn't pass through E. Yeah. What other questions do we have from this lesson? I want to stress that this lesson, just like the beginning couple of lessons in the last unit, is real vocabulary heavy, right? And so these are things that you need to know, and you need to know like as soon as possible. These are things that you need to memorize and need to be in your head, because as we go further and we solve all problems using these vocabulary words, and we do proofs using those vocabulary words, you need to know what they are, right? So these are things that you need to make some flashcards on or whatever, however you do that. You need to have these words and these ideas memorized in your brain, right? If there's any you're confused on, today is the day to ask about them, right? So we need to make sure we're good. What other questions do we have? Sure. 16. Did I erase it? No, good. Good job, me. Okay. All planes intersecting plane EDM. Alright. Now let's kill some of these orange marks. So plane EDM. EDM. So that's this plane right here. That's this one. That one right there. Wants to know all the planes that are intersecting that one. So what's one of them? CLM is. That's this front one. It absolutely is. So that's one of them. That's this one in the front. Right? What else is intersecting that one there? JAE is this back one? Yes, it is. Well, what? What were you saying? Were you gonna say like technically? Oh, okay. What other planes intersect converse of them to prove that they're parallel. So it's the same theorems, just that if alternate interior angles are congruent, then the lines are parallel. That would be the converse, right? So it's the same theorems you learned today, just the converse. So let's do this one. This is number 25 on page 212. So in it, we're given the following picture of what looks like a parallelogram with a couple of lines coming out of it, labeled A, B, C, and D. And this is 1, 2, and 3. And we are given that angle 1 is congruent to angle 3 and AC, segment AC is parallel to segment BD. And we want to prove that segment AB is parallel to segment CD. So, what is a good idea to start? What? Thank you.
Where do you want me to put this?
So when I do a proof like this, I will, on my piece of paper, draw me a little sketch to match the picture so I can scribble on it, right? So that would be a good first step to do. So if you haven't done that, do that. And then I like to label, if you got your different color, this is a good time to use it. I like to label whatever given if it's not already labeled. So I like to go over, so in this example, I would go over here and say, okay, this angle is congruent to this angle, and AC is parallel to BD, right? So that way I can see it, and it's easier for my brain to figure out what in the world is happening. So these two are parallel, these two are congruent, and we're trying to get to, and label that as well, we're trying to get to this one parallel to that one, right? So you can go back to the beginning of where we kind of started with our questions and what is a transversal and what are they? So which lines or line segments are transversals for AB and CD? So if these are the two parallel lines, we're going to want to prove that at some point. Right? If these are the two parallel lines, this is where we're trying to go. Which line segments are transversing those? No, so it wouldn't be 2, 3. Those are, oh, okay. So what letters?
AC.
AC is one of them. What's the other one?
BD.
BD. Okay, so we need to be using one of these two guys. That's our goal there. Right? Okay. We also have a few angles labeled. Are there any, using what we know, I'm going to erase this blue because we might get confused and think that we already know that those are parallel, but we don't yet. That's what we're trying to find out. We'll leave a ghost of it because that's where we're trying to go, right? We know that AC and BD are parallel, right? So we can use the theorems that we learned for this lesson to get that some of these other lines are congruent, or these not lines, but angles are congruent, or they're supplementary, or whatever else. So are there any on here that we can say something about? 2 and 3 are corresponding, which means that they're what? There's two options, either they're congruent or they're supplementary, right? So what are they? They are congruent. So we can go ahead and say that, right? Angle 2 is congruent to angle 3, because you already said, you were correct, that they are corresponding angles. We can go ahead and label that. So this is also the same. Okay. So angle 1 is congruent to angle 3, and angle 2 is congruent to angle 3. What can we say about that?
1 and 3 are alternate exterior.
They aren't quite, right? So that's kind of the tricky bit of that, because they're on two separate things, right? So we're kind of having to go around the horn to get there. Look here, look at some other properties that we've seen before in other chapters. If angle 1 is congruent to angle 3 and angle 2 is congruent to angle 3, what can we say about angle 1 and angle 2? They're congruent. And what property is that? Do we remember? Transitive property. That's true. Angle 1 is congruent to angle 3. Not angle 3. Angle 2. Because of the transitive property. That's absolutely true. That's great. Now what can we say? We're pretty much done. But why are we done? We got one more line to write. Not congruent, parallel, right? It is, but why? And that's yeah, that. Because some specific ones are congruent. Which ones? 1 and 2. What are 1 and 2? Because they're alternate interiors. So that would be, what did I say at the beginning? That would be the converse of alternate interior. Right? So since the alternate interior are congruent, the lines are parallel. We finished. Easy peasy. Not so big a deal. Are there any questions about this proof? Let's do another one. Let's do 27 from the same page. This unit, by the way, this chapter, has in the middle of it, you're going to get there, has the largest algebra chunk in this whole book. We're going to have to solve systems and do all kinds of shenanigans. So you're going to have to lock in on your algebra as well as your geometry in this particular chapter. Because there's a little chunk in the middle where we've got some pretty heavy algebra stuff. We may even solve a random system with substitution today just to practice, because I think we'll have time. Because we're gonna hit that. All right, so this is 27 from the same page. We are given congruent to angle ADC. And the measure of angle A plus the measure of angle ABC equals 180 degrees. And we want to prove that AB is parallel, excuse me, is parallel to CD. So, what should we do now? What did I say on the last one that it is a good idea to do first? Before we even start proving stuff. What?
Marks.
Yeah. Mark the picture. So, angle ABC, so this one, is congruent to angle ADC, this one. And the measure of A, so ABC is 180, ABC. So these two, this one and this one, are 180. So they're supplementary, right? And we're supposed to be proving AB and CD are parallel. So this is what we're proving right here. So those lines there. Great. So what lines are transversing the lines we're trying to prove about? There's three this time. AB is one of the ones we're trying to prove. AB is one of the two that are parallel, but we're going to prove that they're parallel. Which ones are transversing AB and CD? BC, yes. What else? B what? BD, yes, and there's one more.
I didn't say anything about that.
Oh, okay.
Yeah,
No, BA is one of them. These are the lines that we're trying to prove are parallel. These ones right here. Which ones are crossing these lines right here? AD
And BC.
and BC and
The BD.
BD. Yeah, there they all are. Sometimes that can be helpful. What I just did. That's it. When we're doing these parallel ones, the ones you're trying to prove, if you go ahead and like extend it out, then it can be helpful to see, right? There's another tool for your proving tool belt, right?
I just had to think before I say stuff.
You what?
Or I just had to think before I say stuff.
You could think before you say stuff. That's true. That also is useful. Okay. So what can we say? What can we use? How can we use our given?
Couldn't we use the congruent supplement theorem?
Congruent supplement theorem? Is that what you said?
Yeah.
So the supplement ones, the ones that are supplementary, let me grab another color. The ones that are we've at least established something. So we could say, what you're saying, is that angle A plus, or the measure of angle A plus the measure of angle ADC equals 180 because of the congruent supplement theorem. Okay, so this is also in the Cool Kids Club. This one with shift that ever so slightly. So this, actually honestly that's even like way faster way of proving this than what I was thinking in my head. What I was thinking in my head was gonna take a lot more steps, but your route is gonna take us there a lot quicker. Okay? So AD was one of the transversals, right? For the AB and CD that we're looking for. We just proved something about those, right? What can we say now? ABC, what do you say? You're just saying letters. ABC. It's easy. It's 1, 2, 3. What are angle A and angle ADC to the ones that we're trying to prove? Are they corresponding? Are they same side? Are they alternate? Are they nothing?
Can you say that again?
Okay, so the AD, this angle, these two blue angles, those two, what are they to these ones that we're trying to prove with? Are they corresponding? Are they alternate? Are they same side? Are they nothing? What are they? Same side, what? Interior, they're same side interior. Same side interior are what? Same side supplementary, right? So we just proved that they are supplementary, so the converse says that now these are parallel. So we're done, right? So line AB, line segment, is parallel to line segment CD because of the converse of same side theorem. Corresponding angles theorem is the name the book usually uses. Okay. Some good extra proof. Let's solve a system to remind you how to do that. Because we're soon and very soon gonna have to do that. Because we've got a chunky algebra bit in here. This will be in the middle of this, the longest algebra. I don't even know why I'm looking at this book. I'm about to make up a problem. Solve. Y equals 1/2 x minus 3 and y equals negative 2x plus 4. Yeah, system. The system is set up, and I put these in slope intercept, both in slope intercept form, and I did that on purpose because the ones that we're going to do in this chapter will probably have them in slope intercept, because you'll have to first find the equation in slope intercept and then find where they cross, which is the solution to the system, right? And so that's how you'll see it. So how do we solve this? And I'll give you a hint that we probably want to use substitution. It's going to be a lot easier than trying to use elimination on this problem. I know it's been since last year, so I'm going to tease out some answers. What do you think we're going to do? Substitute what for where? What do both of those equations equal? Y. They both equal y. That's true. So since they both equal y, we could substitute this in for y in this equation. we do to solve this equation? Add 3 to both sides, sure. Why not? What? You can't combine like terms, they're not like terms on each side, on the same side. Add 2x sounds fine. It's 1/2 x plus 2x. 2 and 1/2, I'm gonna write that as 5/2 because it's gonna be easier to deal with later, right? 5/2 x equals 4 plus 3 is 7. Now what? Divide. How do we divide fractions?
The reciprocal.
We do multiply by the reciprocal. Times 2/5. Times 2/5. Right. 2/5. So x equals what? You don't need no calculator. Put that down. Do you know what 7 times 2 is? Yes. So you don't need no calculator. What's 7 times 2/5? What's 7 times 2? 14. So 14/5. Okay. So now that we've got x, how can we find y? Just substitute. I'm going to actually substitute in the one with the fraction. I know that's a little scary, but since that's going to pre-reduce it, we do it that way because we ended up with an ugly fraction. Right? But you can substitute in either one. When you do the ones from the book, you won't have ugly answers, probably. Probably. Maybe not, but probably. The reason why this one's ugly is I just made it up. Okay? So what's 1/2 times 14/5? 7/5, right? Maybe so. And if we go ahead and multiply the 3 times 5/5, we end up with 15/5, right? You can do this using your calculator as a tool. Don't stress too much, but if we do a few things that we've known how to do for a long time, you don't even need one. All right, what's 7/5 minus 15/5? Negative what? Fifths. We have to do one more thing, right? We gotta write our answer the right way. How do we need to write our answer? Yeah, an ordered pair, right? 14/5, negative 8/5. Let's do one more of these. This time we're gonna do it as a GP, a guided practice. So I'm gonna write it, you're gonna start it on your own, and then I'm gonna could substitute it in either direction. I'm gonna substitute this one into here, but you could do it the other way around. But if you're feeling a little shaky on it and you wanna follow exactly what I'm gonna do, you may wanna do it this way. You'll get the same answer if you do it the other way, and if you do it correctly. I don't know what I just did, because that's dumb. I'm stupid. So you have to think about too many things. I made a dumb mistake. That all doesn't equal X. What am I doing? Why didn't y'all tell me I was being stupid? That all equals Y. How about we plug it in over there? That makes more sense, right? I'm starting to question your basic math skills. Me too, bud. Me too. So pause a second. If you're checking your work with my work, you might notice I wrote something funny. What something funny did I write, and why did I write it that way? Yeah, I wrote negative 21 thirds. Why did I write it that way instead of saying minus 7x and minus 7x? Let me answer this question real quick, because I think the answer is just yes. Sorry. Hello? I did. So it's up here at church. Okay, sounds good. Bye. Sorry, I have to get a thing to a dude. Why did I write it that way? This equals 7, right? Negative 21 thirds equals negative 7. Right? Because now I can do it in my brain. Ready? Okay, you keep going about your business. You're going to use your calculator and not do it that way. I just like to stay in the habit of doing it that way, do a little middle school math, keep myself going in a good direction. This is going to end up even uglier than the first one. On GP, you can ask questions too, by the way. If you're like, there's something you're confused and you're like, I don't know what to do or why to do, make sure and send up a flare. should get the same answer if you did it right, even if you do it a different way. What? Okay, so did you get X right or no? Okay, so when you subtract the 7x from both sides, or 7x, did you get negative 23/3? Got 19th. Okay, so they're both negative, right? So you have to add and keep the sign of the bigger one. I mean, of both of them. So yeah, it's kind of a sign mistake. That's what happened. So that is what you get. If you have any questions about that. Three and 2/3. Which one will be? All right, kids. We'll see you on Tuesday.